Okay, now we want to see what E has to do with the expression 1 plus r over n raised to the nt, which again is what you would multiply, well, 1 plus r over n is what you would multiply by your principal at annual rate r compounded n times annually to get the principal after one of those n periods per year. And then you raise that to nt because you do that nt times in t years. So there's our expression. Let's see what we can do with it. Now we have said that E is defined to be the limit. Now before it was as n goes to infinity, 1 plus 1 over n to the n, but you notice that I'm using m here instead of n, and that's simply, it's totally equivalent, but I'm using m simply because I'm using n here. Okay, and I don't want to have the same letter. Excuse me, I hope that wasn't too loud. Just ate something. Okay, so we want to replace the expression 1 plus r over n with the expression 1 plus 1 over m. Because, of course, what we want to do is we're taking the limit as n approaches infinity of this thing. If we can somehow replace 1 plus r over n with 1 plus 1 over m, then we're getting close to this expression. Well, that's easy to do. If 1 plus r over n is equal to 1 plus 1 over m, then what does m have to be? So m must equal what? You should pause, figure that out. Okay, well, m must equal, maybe you have to write something down to figure it out. Maybe you have to be careful. So maybe you write out, well, this will equal this if 1 over m equals r over m. That might be obvious then what m has to equal, but in case it isn't, you simply multiply both sides of this by the common denominator, m times n, and you get n equals m times r, so m equals n over r. And once you've got that, it's obvious. If m equals n over r, and that n almost looks like an m, there's a little something on the board there, maybe something came off the chalk, m equals n over r, then 1 over m is r over n, be the reciprocal. So m just has to be the reciprocal of r over m, and these are equal. So m must equal n over r, in which case n equals what? Well, if you wrote this out, you would see that n equals m times r. But if you say that m equals n over r, it's easy to solve that for m. And you see that n has to equal m times r. N equals m times r. And why is that important? Well then, our expression is 1 plus r over n raised to the nt. Okay, replacing r over n with 1 over m, where m equals n over r. Since n equals mr, then we're going to have mr up here, and we've got the whole expression in terms of m. So n equals mr, so nt is equal to mrt. And here we sort of have this expression. We've got 1 plus 1 over m to the m here. But what are we going to do about that rt? Because we just don't want that rt on there. Well, by the laws of exponents, and as I say, people are generally pretty shaky about the laws of exponents when they get to the stage that most of you are at. Hopefully that's not the case for you, but if it is, then you really have to think about the laws of exponents. Unfortunately, in my opinion, we're trying to teach too much algebra to people who will never understand it. That's not you. That's the people in your class that are holding things back. And it's not their fault. Either there should be a special algebra class where you really learn the stuff, or teach quantitative reasoning to people who will never understand the algebra that well. You give them enough algebra and so forth. I don't know. I'm not in charge of the school system. The people that are have to struggle with these questions. Okay, so little digression there, but okay, so the laws of exponents tell you that 1 plus 1 over m raised to the mRt is the same as 1 plus 1 over m raised to the RT. Okay? It's just, you're taking a product, or you're taking a power of a power, you're going to multiply the powers. So 1 plus 1 over m to the power m raised to the power RT, you multiply the powers, you get 1 plus 1 over m to the mRT. Okay? And that can get a little confusing. You've got to be careful with the laws of exponents. Write them out carefully, make sure you know the laws, and make sure you apply them correctly. Check yourself. Okay, so anyhow, we have this 1 plus 1 over m to the m raised to the RT. Now, I'm not being real formal about limits because it's something you haven't really studied unless you've had a calculus course, most likely. But as n goes to infinity, so does m. Since m equals n over r. Okay? M equals n over r, so m is actually bigger if r is a reasonable interest rate, if r is any number less than 1, like 0.05 or 0.12 or 0.1. M is going to be bigger than n, so certainly as n goes to infinity, so does m. Well, even if r was much bigger, there's no limit to how big n is going to get, so there's no limit to how big n over r is going to get. So since m equals n over r, thus the limit as n goes to infinity of 1 plus r over n to the nt equals the limit as m goes to infinity of 1 plus 1 over m to the m raised to the RT. And RT doesn't change when m does. And again, you know, there are a couple of formal steps that you would want to understand, and I'm not going to explain them to you here. It'd take us too far away from what we need to see. It follows that since the limit as m goes to infinity of 1 plus 1 over m to the m is e, and since RT doesn't depend on m, that this is just e to the RT. So our final conclusion is that P of t equals P naught well, my statement's a little clumsy now, but I'll go with it. P of t equals P naught e to the RT. Model's principle at interest rate R, probably blocking the board, we'll step away. compounded continuously. Okay? And that's pretty much it. Now I haven't said what P naught is, I've said it previously. Make it a little hard to read this, but then I add on where P naught is the T equals 0 principle.